Hey folks, and welcome back to our next unit in geometry. We're actually going to be working on the XY plane. So if you have graph paper for this unit, it's a really good idea, but I know that we might not be able to get graph paper right now, and you might not have it. So you don't need it, but you are more than welcome to use it if you have it. Today we'll be discussing the distance formula. We used it a bit with circles. We're going to circle back around, and we're going to see where it comes from and how it's related to the Pythagorean theorem. Let's take a look. So our aim today is how do we use the distance formula? We've seen the distance formula before, but we're going to show where it comes from. And our first example is right here. Find the distance from -2, 1 to 3, 3. You might want to pause and write in the aim and the example. So the first thing we need to do, and it's really helpful to do so, is just draw a quick diagram. So even if you don't have graph paper, draw one out best you can. So this is our quick diagram. It might not be the best in the world, but oh well. Here's how we're going to find the length. We have, with any of these, a right triangle. You can think about the x and the y as two separate distances. From here to here, this is dealing with my x because it's parallel to the x-axis. It's just going to be 3 minus -2. This 3 minus that -2. This is going to be this 3 minus that 1. 3 minus 1. Well, this is just going to be a distance of 5. This is going to be a distance of 2. Well, remember, this is a right triangle. We know this is 5, that's 2. So this has to be, let's call it d for distance. What relationship do we know has to be true? Well, I know that d squared has to be 5 squared plus 2 squared. That's just the Pythagorean theorem. So d squared is just equal to 25 plus 4. Well, that's just 29. So that means d is equal to the square root of 29. 29 is a prime number, so we can't do anything with it. So we just found the distance from 2 points. And this leads us into our distance formula in our next example. So in that example, we found the distance between 2 points, and they had clear, easy to see values. In our next one, we're going to do it where our points don't have values. They're just two nebulous points of x1, y1 and x2, y2. We're going to apply the distance formula to it, and we're going to make a concrete formula for our distance. Let's take a look. So here we're going to do the exact same thing, except notice our points don't have any value to them. It's just x1, y1, and x2, y2. So we're going to call this first one the blue point to make life easier, and then we're going to call this second one the pink point to make life easier. And we're going to use the ideas we used in our first example to help us out. So we saw in the first example that to find our x distance here, I did one x value minus the other x value. It didn't matter that they were negative, I just had to use it. So I'm going to have my one x value of, well, the second one, x2 minus x1. That was my x distance. And what we ended up doing with that x distance, in the first example it was this, was we had to square it. So I'm going to square whatever that is. And then we have to keep that same order. So what I did here was I did the 3, because it was in the same coordinate, both of them, the x and the y. So I'm going to do, well, 3 minus my first y coordinate, y1. Well, not 3, Gallagher, y2. And then what we ended up doing with this was squaring it up here as well, so I'm going to square it here. And this was all equal to d squared. Well, last but not least, we had to get d by itself, so we got rid of the square. So we get our distance formula by doing that. It's going to be x2 minus x1. This is a lot easier on a smartboard to change colors. Squared plus y2 minus y1 squared. And all of it's under the square root. Now you might be wondering, but wait a second, does it matter the order of the points? Like, could I have done the first example in a different order? What if I had chosen x2 as y2, or x2 as x1? You can totally do that. The reason being, since this is squared, even if you get a negative in here, it's going to become positive, because negative times negative. That's the distance formula. So let's apply this distance formula. We're going to do it with a new example. You can sketch out this example if you want and still use the Pythagorean theorem. That is always, always, always an option here. However, the distance formula can be a bit easier. Let's see. So we're going to do this one entirely using the distance formula, and we're not even going to draw a graph. No drawing a graph. When in doubt, graph it out. You can still draw a graph, I'm just not going to do it. First thing first, I'm going to determine which one of these is going to be which. So I'm going to just call this one x1, y1. And I'm going to call this one x2, y2. It helps to label them out, trust me on that. So I'm just going to plug everything in now. So x2 goes here, y2 goes here. There's a negative, that's okay. Next, x1 goes here, that's negative 3. There's a negative, that's okay. y1 goes here. So now we're just going to combine these two things together. We got two negatives, that's a positive. Negative 2 minus 4, that's going to be negative 6. Notice I put parentheses around the negative, just so if I plug this into a calculator, it's not going to square positive 6 and then make it negative. In fact, you can put parentheses around this too. You can plug this whole thing into a calculator if you want, but it might not always give you a whole number answer. You just got to work it out. Well, this is going to be 64 plus 36. Well, that's the same as the square root of 100 because I just add them. Well, that means that d is equal to 10. Now, as you've learned in the past, you could have a positive or a negative. The reason we don't have a positive or a negative here is because we're always talking about distance in terms of a real-world value. That can't be negative. You can't walk negative 5 blocks. Cool, that's our answer. Awesome, so we've seen 3 examples with the distance formula. Go ahead and give that delta math a shot. As always, if you have any questions, see me during office hours, add a private comment, add a class-wide comment, send me a message on Jupiter, email me, send a smoke signal, or send a carrier pigeon. It will know where to find me. Have a great day, folks. Stay safe.